Welcome to Minikun Tutorials. Today we're going to perform students T-tests for independent groups in Excel. So you would ask yourself, why did I underline independent groups? This is very important. Students T-tests can be carried out for either dependent groups, also known as paired groups, or independent or unpaired groups. When we talk of dependent groups or paired groups, we are talking about maybe repeated measures. For example, we can measure the temperature of patients with two different thermometers. So we would have temperatures measured with thermometer A and then temperatures measured with thermometer B. These results may vary depending on the precision, what do we call it? The precision and then the exactitude of each instrument. So we can calculate the mean temperature measured by thermometer A and the mean temperature measured by thermometer B. We can perform students T-test. However, this will be a students T-test for dependent groups because these two groups, those measured by thermometer, the temperatures measured by thermometer 1 and the temperature measured by thermometer 2 are paired in a sense that they both both thermometers measure the same patient. You get what I'm saying? Now, another good example is measuring height at different ages. We can measure height of patients at age 1, then their height at age 10. We can calculate the mean age for age 1 and then the mean age for age 10. So this has to do with what? Paired data. Regards to independent or unpaired data, the two groups are mutually exclusive. That's to say, they don't depend on each other in whichsoever way. For instance, comparing the mean age of men to, or the mean weight of men to the mean weight of women. So our studies will be carried out on this data set. And as you can see, this data was collected on a total sample of 160 patients. So we have the patient's ID, we have the gender as to whether the patient was accompanied or not, and the weight of the patient and the height. So we will perform what students T-test for this. And one important thing, by definition, students T-test is carried out. Okay, let me limit it, my definition to independent groups. It's carried out on two variables. One, a qualitative variable, in other words, a nominal or a categorical variable, which is our dependent variable. So this has to be numeric. And then an independent variable that is qualitative, in other words, I'm sorry, let me take it again. Students T-test is carried out on two given variables. Number one, a variable that is numeric or quantitative in nature, not qualitative. I made a mistake. A variable that is numeric or quantitative, for instance, weight, or for instance, height. So, and then an independent variable that is qualitative. In other words, it could be nominal, it could be ordinal, it could be simply categorical. You could call it a factor or a character variable. So the aim of a student's T-test is to study the repartition, in other words, the distribution of the quantitative variable. In other words, yeah, for instance, age, for instance, height, between the responses of what? The qualitative variable. For example, what is the mean age of men? What is the mean age of what? Women. Or what is the mean weight of men? What is the mean weight of women? Based on the sample observations, we could look at these two means and say, you know what, there's no any significant difference between them. However, because we've carried out our studies on a sample, we cannot conclude. If we had carried out a study on the whole sample, we could have concluded that, okay, maybe they are different, or they are not different, or that they are not much, that the difference is not significant. And for this reason, we have to perform a student's T-test to verify whether the difference that we've observed between the mean weight of men and the mean weight of women on our sample, is it statistically significant within the true population? Because the difference that we may be observing between this and this may be due to sample error, just sample fluctuation, for the fact that by random sample error the two means differ, or we may even have a case where the two means do not differ, but in either case there must be a difference for you, then that would call for the performance of the t-test. If there's no difference, then there's no need carrying out the t-test. So first of all, there must be a difference that you've observed. Either the mean age of women will be less than that of men, or the mean age of men will be less than women, and that will, on our sample, that will probe the, what do we call it? So I hope everything is clear. So one important thing to note is that with a categorical variable, it can have more than two responses. This is actually a dichotomous, in other words, a binary variable like gender, or maybe accompanied yes or no. But in a case where the variable takes more than two responses, for example, let's say ordinal variables, let's say variables that are in ranks 1 to 5 years, 2 to 3 years, to 5 to 10 years, 10 to 15 years. These are three responses. This is just an example. In that case, we'll be comparing three groups. So we'll be testing whether three means are equal. At least there is a difference between these, any pair of these three means, you see. But in our case, it will be simple. It will just be two, two groups, males and then females. So without wasting my time, we're going to perform our t-test, trying to compare the mean weight of, or the average weight of men to that of the average weight of women. And to do that, first of all, we have to, I'm trying to be, to follow everything, the steps systematically. So we first of all calculate the means, we followed by our hypothesis. We have already formulated the hypothesis. In case there is no any relationship between gender and weight, then we expect that in the true population there won't be any statistically significant difference between the two means, the mean weight of men and mean weight of women. On the contrary, if gender is related to weight, then we would expect the alternative hypothesis to be true. So, but one important thing to note is that when we are performing t-tests for independent groups, there are two types. We have two t-tests for independent groups with equal variances, and then t-tests for independent groups for unequal variances. For this reason, we have to perform the Ftest, in other words, Fisher's test of variances, to know whether the population variances are equal or not before we can proceed to choose which test to do. So, and after which we conclude. So without wasting my time, let's calculate our sample means. So we calculate the mean or the average weight for women and the average weight for men. To do this, we'll just simply do it with our pivot table. So to insert a pivot table, you click on insert. Let me zoom so that you click on insert, then you click on pivot table. So when you click on pivot table, as you can see, it gives us this dialog box. You have the choice. You could put your pivot table right here on this page, or you put it on a new sheet. So we put it on a new sheet as it is here. So just hit OK. So it has already set our pivot table on the new sheet. Here it is. So this is now to construct the pivot table. It's a matter of dragging this and putting it into the columns and the rows. So sorry for the interruption. So as you can see, these are the pivot table fields, and the pivot table will be constructed here. So what do? Since we want to have we want the average weight for, or the mean weight, or in other words, it's the same as the mean and average is the same. Since we want the average weight for um, men and then women, so we simply drag the gender variable into the columns. So when we drag the gender variable into the columns, what happens? Simply drag gender into columns, and then we drag the weight into values. So it will give us what by default is going to sum up the values, so it will give us the count for, what should I say, the weight for men and the weight for women. But that's not what we want. We want rather we don't want counts, but we want rather the average, in other words the mean weight. So as you can see our results here, it has given us the counts or whatsoever. That's not what we want. We simply want the average weight for men and average weight for women. So to do this, what do? We click here, and then we click on value field settings. Then we click, instead of count, we don't want count, we want average. So we simply select average and hit OK. As soon as we do that, it will calculate the average age for men and average age for women here for us. So we copy this. The average age for women is this. Average age for women is this. Okay. I'm sorry, my PC is in French, so when you see comma in French, dots in French, they usually write comma, so sorry for that. Sorry, I've increased it, but that's not what I intended to do. Okay, now let's go for the average of men. The average weight for men is this. Okay, so now the average age of weight, for men is 64.23 kilos, and that of women is this, and that of men is this. So I think we are done with this. Now, looking at these two averages, somebody would say there's no any statistically significant differences. But since we've carried out our studies on a sample, we cannot conclude. We have to perform the t-test, as I said. Now, we've already talked about the hypothesis formulation. Now we will go ahead and perform our Ftest test for variances, to know whether the population variances are equal, to know whether we perform students t-test for independent groups with equal variances or unequal variances. Now, to perform the Ftest is simple. Let's come back to our data set. Now we will create two groups on a different worksheet, preferably, where we will have a group of all the weights for men and a group for all the weights for women. So we open a new worksheet, and then we write weights for men, for women first of all, our mothers first. So women, then we have weight for men. Okay, let me try to make this bold and clear as possible. I think it's okay. Let's leave it like this. Okay, so we have weight for men and weight for women. So we get back to our worksheet, and then we just simply use the filters and then we filter the weight for men. I hope this is something easy to do. To filter, you apply the filters, filter. Now we can select for only men, so we can select everything and select first of all for women. So we hit OK, and then it gives us this. So we simply copy the weight for all the women. Good. Control C to copy. Now let's get to worksheet. So this is the weight for women, and we paste it here. When you are pasting, please paste with values, or what should I say, yeah, in values, not preferably. We do the same for men. So to first of all, you have to remove the filters and then do a second filtration. So to do that, you simply click here, then clear the filters, and then now select men and select everything. Now select only men, hit OK, and then copy the weights for the men. I think it ends here. Okay. That's okay. Now let's get back to our worksheet, then paste it as usual. Okay, now we are done. We have our the weights for men and the weights for women, and we now try to analyze or calculate the, what do we call it, to test the variances of each group, to know whether the variances are equal or not, before we can now choose which Ttest of independence to perform. So now to perform your Ftest, how do we do? You have to click on data. Let me show you how to do it. You click on data, and when you click on data, you move right and you will find your data analysis tool pack. In the case where you don't find data analysis tool pack, by clicking on data, I will show you how to let it appear here. You click on file. If it's not there, you click on file, then you click on options, after which you click on complements, add-ins, that's in English, add-ins. Then you get down and click on go. As soon as this dialog box displays. So if I should uncheck this and hit OK, automatically the tool pack will disappear. See, it has disappeared. If I want it to reappear, you just simply check it, and that's it. So click on options, you click on add-ins, you click on go, you check analysis tool pack, hit OK, and it will display again. Here it is. So right now we're gonna go ahead and perform our Ttest, our Ftest of variances, to know whether the variances are equal or not, to know which Ttest to select. We'll have to choose. So now to perform the Ttest is simple. Or sorry, I'm mistaken. Ftest, first of all, you click on data analysis. Now that your data analysis toolpack has displayed, you click on it. Then after clicking on it, you simply come here. It displays all the possible tests. Now we'll perform first of all our Ftest for, you see, Ftest two sample. Sorry for the interruption. So as you can see, Ftest two sample for variances. So we are going to compare the variances of the weights of women and to that of the variances of or to that of men. The variances of the weights of men to the weight of women. So we go ahead and perform our Ftest. So we simply hit OK. And as soon as we click, we hit on OK, a dialog box will display. As we wait, let me minimize it so that. Okay, here's the dialog box. And as you can see on the dialog box, we're going to select our, what do we call it, the range for which the range variable 1 consists of what? That's group 1. That has to do with the, sorry, let me go up. I don't really enjoy zooming, but to make things clear, let me take it again. Yeah, so as you can see, this group 1 for women, group 2 for, or variable, first variable has to do with the group of women, second variable has to do with the group of men. So let's go ahead and perform our Ftest to test whether the variance of weights of women is equal to the variance of weights of men. If it's true, there is a Ttest for, what should I say, independent groups for what should I say, weights equal variances. In the case where they are not equal based on the Ftest, then there is a Ttest also for independent groups with unequal variances. So let's go ahead and let's take it again. We simply click on the data analysis toolpath. As usual, you hit on it and then this dialog box displays. You select your Ftest for 2 variances. You hit OK. Now when this dialog box displays, you click here to select your first range, which is this. I don't know why it keeps on. Let's scroll up a little bit. Okay, so this is the weight for the men. So we select this. We scroll down to select the for the women, sorry. After which we select for the men too. Okay, this okay. Now we click here, and now we click on the second range to select the range for the men. So let's scroll up a bit. Okay, and sorry, let's go on. Okay, then we click here. Now we select the output range. We have the choice. We could put our what do we call it, our results, our Ftest results on a new worksheet or the existing worksheet. If you would like to put it on the existing worksheet, then we hit on output range here, and then we click here and select where we want to put it. So we can put it somewhere here, just right beside the 2 groups, and then we hit OK. We have to select the label. We have to indicate that the first row contains the labels for our variables, which is this and this. So we have to indicate that this the first row contains the labels for our variables. Otherwise, it will try to analyze this as a qualitative data. There's another important thing that we'll look at after this, but I'll first of all hit OK, and then I'll show you, because my data set is my PC, the Microsoft Office that I'm using is in French. So since it's a French software, what happens is that in French, when we want to write point, for instance 2.6, we write 2,6, and because of that, when I was the data set was actually in French, but I decided to translate it into English because I want to make an English tutorial. I don't need to explain everything, but because of this, I had to convert the comma into points in order to make the data set look like the English system. But I think things will get worse, and I will have to convert them back to comma, otherwise it will give us error. because it will recognize point as a non-numeric what should I say, digit, so let's hit OK. We hit on labels to tell it that, then we hit OK. See, it has given me an error. It's saying that not trying to type whatsoever. Let's read it completely. What is it saying? We had a problem whatsoever. What with this formula? Try clicking insert to whatsoever, so that's what I was just saying. So let me hit OK and see what happens. What do we have to do? Let's close it, and then I come here and I'll show you the data. This actually has nothing to do with your case. If you are using a PC that is in French, if everything is all right with you, this is just my personal problem, because my Microsoft is in Excel. So the data it does its calculation with a French system, and for that matter, if I have something that is supposed to be comma but I kept point, it will, let me minimize and show you. As you can see, if I should scroll down, for instance, figures like this is not acceptable. In French, it's supposed to be what do we call it, comma 6, something like this, not as let me go back. So it's a little bit okay, let me hit on home. Increase, it's giving when I even try to increase the decimal places, it's not able to recognize that point, what I'm just talking about. So I'll quickly have to replace every thing here. Never mind what I'm doing, this just has to do with my PC, because I converted the data from French to English. So I replace all the point so I will have to replace the point by the comma as in the French system to prevent getting these errors. If your data is all right, just go ahead, don't ever mind. So I have to find all and replace all. Okay, I hope everything has been replaced. Close and see what happens. Let's retry our test and see what happens. So we click, as usual, we click on our data analysis toolpath. Where is it? Sorry, we have to click on data. We click on data analysis toolpath, and then Ftest. We hit OK. Let's just hit OK and see what it will tell us again. Hit OK. See that it has now worked after replacing those things by comma, because in the French system we don't write point by point or dot. We have to put comma. You have realized that even the results are with comma, because my PC is in French. The Microsoft Office is in French. It's a French software. Okay, so as you can see, it has given us, let me highlight it, let me make it, it has given us the F statistic, which is right here, so let me make it red so that, okay, it has given us the F statistic to be 0.859 something, this point, as I was saying, in the French system. And then it has given us the F statistic, the observed statistic, and this is the critical value, or the theoretical statistic, which is this. So what do we say? As we can see, the F statistic is greater than what? It's greater than the, what do we call it, the critical value. Sorry. So the F statistic is greater than the critical value, which is this. Let's make it red so that everything will be clear. Okay. So when the F statistic is greater than the critical value, then what it means is that we have to reject the null hypothesis. Because here it has not given, we are not, I don't think it hasn't given us p-value, so we are interpreting with respect to the statistic. When the F is greater than the critical value, at that point we have to reject the null hypothesis. That's to say the two variances, which is this and this, are statistically different or significantly different. Let me put it that way. This means these are the sample variances, but upon doing the F-test, it has shown us that these two variances are statistically different or significantly different. And for that matter, we have to, let me go back to, yeah, so it's saying we have to reject the null hypothesis. Rejection of null hypothesis. So after rejecting the null hypothesis, what happens? After rejecting the null hypothesis, what it simply means is that why? Because the F statistic is greater than the critical value. If it's greater than the critical value, then what it means is that we have to accept the alternative hypothesis by saying that the variance of the women that and then is either less than or greater than that of what? The men, but they are not the same, as you can see. So it's greater than that of the men. The variance of the women is less than that of the men, I guess. Okay. So from now, it means when we are to perform our t-test, we perform our t-test for independent groups with what? Unequal variances. So let's go ahead and do that. We get back to our Excel and then we click on the same data analysis toolpath right here. Where is it? Click on data, click on our data analysis toolpath, and this time around we will now perform our t-test. You realize that we have, as I was saying, for paired data we only have one t-test or one type of t-test for paired data. For independent or unpaired data, we have two types, for equal variance and other one for unequal variance. So our Ftest has revealed to us that the variances of the two groups are unequal and we have to perform this one. So we hit OK. We have to perform two sample assuming unequal variances. We hit OK, then it gives us this dialog box as we did before. We select the range once again to perform our t-test, starting with our mothers. Simply scroll down. Okay, then we select the range for the second group. We click here and we have to scroll up. Okay, then we select for the second group. Now we hit OK, and after which we have to indicate, as usual, the first row contains our labels for the variables, and after which we leave alpha to be 0.05. It's okay. We can hit OK. No, we have to select the output range. We have the choice. We could either put it on a new worksheet or we put it on the existing worksheet. So let's try to put it on the existing worksheet, somewhere below we click here and then we place it somewhere here. I hope it works. If not, we put it on an existing worksheet. We hit OK. It has worked perfectly. So this is our t-test results. you know. So as usual, let's enlarge this a little bit. Okay, very good. So we have weight for men and a weight for women, and as usual it gives us the t statistics, which is this. Let me make it red, sorry, highlight it. Okay, so we compare the statistic to that of the critical value, and the critical value, it is a, so one thing we have to note is that this is bilateral. It's not a unilateral test, so it's a two-tailed test. Why? Because looking at the what do we call it, the alternative hypothesis, we are saying the null hypothesis is saying the within the what should I say, the population of women, the average weight of women, or the average weight of the women population is equal to the average weight of the men population. And then the alternative hypothesis is saying they are unequal. That's to say they are either less, or the mean population of the, or average weight of the women population is either less than or greater than that of the men population, but they are unequal. So it's bilateral, either side. So for that matter, we have to select, sorry, let me, okay, for that matter, this has to be, we have to select the two-tailed test results, not one tail. Okay, and comparing these two, what do we say? We realize that the t statistic is less than the critical value. So if it's less than the critical value, it will not enter in the rejection zone if you look at the t distribution curve. So for that matter, we are not going to reject our null hypothesis. But not failure to reject the null hypothesis does not mean that we've accepted it. This, the critical value is negative 0 point something and it's less than 1 point something. The t statistic is negative 0 point something and it's less than the critical t value, which is or t statistic, which is 1.9 something. So we cannot reject the null hypothesis, but it doesn't mean we've accepted it. Probably our data here, let's say the number of subjects were not that much, what should I say, were not, the sample sizes were not that much large to, prove this difference. So maybe due to lack of test power, low test power, we've not been able to prove that, okay, the sample, what should I say, the two population means are significantly different. So maybe we cannot, our conclusion will be as follows. So after our t-test, what is our t-test result? With what our conclusion would be as follows: we've rejected the null hypothesis. So failure to reject the null hypothesis. We haven't rejected the null hypothesis. So failure to reject the null hypothesis. And failure to reject the null hypothesis implies what? Implies we cannot conclude that there is a statistically significant difference between the two population means. Between the two population means or averages, it's up to you. It's the same. So let's correct this. Okay, and that's the conclusion of our test. The test results showed us that we've performed our Ftest, and then the Ftest showed us that we had to reject what the null hypothesis. So upon rejection of the null hypothesis, because the F statistics was what greater than the critical value, then we had to perform, because we rejected the null hypothesis, it means this was true, alternative hypothesis was true, and so we went ahead and performed what our chi-test, I like saying chi-square test, our t-test with what unequal variances, and then the t statistic was less than the critical value, and for that matter we could not reject, what should I say, we failed to reject the null hypothesis. So failure to reject the null hypothesis, failure to reject the null hypothesis, because the critical value, we could have, it depends, if we had gotten the p-value, we would have been comparing it to 0.05, but since we don't have the p-value, we have to interpret with our statistic. So comparing it to the critical value, if the statistic is greater than the critical value, we have to reject the null hypothesis. If it's, by now case, for the t-test, it was less than the critical value, so we cannot reject the null hypothesis. And for that matter, we have to conclude by saying that we cannot conclude that there is any statistically significant difference between the two population means. We cannot. Why can't we conclude? Maybe our sample size was not that much large, or sample sizes were not that much large to prove this difference. So maybe it might be due to lack of test power. And this comes to the end of our tutorial on t-test for independent groups. If you have any question, please do not hesitate to leave your questions, and I will attend to you in the comments box. Please remember to share, like, and subscribe for more videos. We have a lot to learn together. Thank you so much once again, and see you in the next video. Bye.